Google Developer Student Club.
Hello, everyone. Thank you for joining us. Welcome to our talk. So, do's and don'ts of GraphQL and REST API services. To introduce myself, my name is Alexander. I'm Google Developer Student Club lead at Conestoga College here in Waterloo, Ontario, Canada. And today we have a guest speaker, Deepa. So I will pass it to you, Deepa. And yep.
Yeah. Hi there. Hello, everybody. Thank you so much for joining today on a Saturday morning or evening, whatever time zones you are in. Thank you so much for joining us. And thank you so much, Alexander, for giving me this opportunity to talk. And today, let's see what are the do's and don'ts of GraphQL and REST API. Little about myself. I'm Deepa. I'm a developer at Adobe. I'm also involved in a few communities outside of work. I'm the organizer for Google Developer Group San Jose. And then I'm also an ambassador at Women Tech Makers. I also write blogs. So these are the social handles that you can connect with me. Fun fact about me is I love coffee. So if you're up in the San Francisco area, let's catch up with a cup of coffee. Moving on. So what is that? I made up some assumptions that those who are attending this talk would know something about web development. You have some knowledge about what is a client-server architecture and what is a database and what does it do and things like that. So with that assumption, and start with today's agenda. We'll talk about the basics of API, and then we'll deep dive into REST API and GraphQL as well. And finally, I have a small quiz. Don't worry, it's going to be very short. It's all true or false kind of questions. I just wanted to know whether if you followed something along the lines with this talk. So we'll also break for Q&A in between rather than waiting till the end. So Alexander, please let me know if there are questions in between. Like we will break up accordingly.
Yeah, definitely. And just to make it clear, if you have any questions, please submit them into the chat, and then I will just ask Deepa them. So, cool.
So to start off, let's start with what is an API and how does it work. API is Application Programming Interface. It's a software interface that allows two applications to interact without any user intervention, right? For example, you have an Android phone. You're trying to check the weather for San Diego, but you live in San Jose, right? And you're trying to get it. Google does not, they don't have their own APIs for weather. Probably they would have had it, but they would integrate it with the Weather Channel. And then once you type in and try to find what is the weather in San Diego, it connects to the Weather Channel API, and then Weather Channel in turn gets the data and displays it on your Android phone. So with that said, here is, like I said, the client could be, a client program starts an API call to receive information, most often known as a request. And an API call, the API calls the web server after receiving the valid request, and server responds to the API by sending the requested data. The data is finally transferred to the front end. It could be your mobile phone or your browser. So a small brief history is how APIs have evolved over time. As you can see, it started off with a remote procedure call, and then there's something called as Corba, and then SOAP API, REST, and Graph. We're going to be focusing more on the last two today. So there are different types of API based on certain needs. For example, based on the purpose, you would have system APIs, process APIs, and experience APIs. And strategies would include internal API, partner API, and external API. And there are based on types, architectural styles, sorry. It could be, these are different architectural styles that are available. And REST and GraphQL is one of them, and SOAP is also another one. we'll be focusing more on this part of API today. Understand that based on the purpose, strategies, and styles, APIs can be designed. So when we talk about APIs, there are different elements to an API. APIs are a collection of software functions and procedures. So the procedures are often referred to as routines to perform very specific tasks. For example, if you have a, if you are using Twitter, if you use Twitter API to fetch some data, right, for analytical purposes, you have to write some procedures for that, right? So that would be one of an example. And protocols are formats that are used to communicate between the applications, basically how the exchange happens between these applications. And tools are how do you build APIs with these. There are a set of couple of tools available to develop APIs. One is Swagger, the other one is also Postman. You can use that to build or develop your APIs. And just to give you a stat, this I picked up from this is a recent data where during the pandemic there was an increase seen in the United States in the usage of APIs for about 135% and about 160% increase in India. And that's, there's also currently over 17 million people use APIs on a everyday basis. So imagine that there's a lot of communication happening here. So with that said, it's like APIs are everywhere. And if you are thinking of APIs, if you're trying to post a issue or post a tweet in Twitter, or you are trying to control a thermostat from your mobile app, or your camera detection or security camera detection for motion field. So all these things happens because APIs are there and it's all connected to the internet. Okay. So it is, APIs are like, from automobiles to doorbells to dishwashers and wearable devices. It's everywhere. So we have it. So why do we need it? We need to bring applications together. It was not possible before that you could do any operations like turning your thermostat on and off from your mobile. It was not possible. So now with APIs, it is possible to bring applications together. And it is built to share data. So you can share data and also execute predefined processes, right? With that said, you can collect a lot of data from it, and then you can sort them, and you can also migrate data faster and easier using APIs. So I want you to understand that there are these two terms, a web service and API. A web service is a software system that is designed to support machine-to-machine interaction over a network. So when we talk about APIs and web services, there are two technologies for transferring data between applications. So, but then web service requires a network. And always remember, all web services are APIs, but not all APIs are web services. What do I mean by this? For example, you have your laptop, and if you're using a Mac, you have a camera, you take a picture from photo booth or something, and then it goes to your photo app, right? It does not require a network, but still it connects and it automatically syncs it to your photo app. You can take that as a API interaction, but they are not web services because web services require a network. So these are the steps for a life cycle of an API. As how do you design your API, right? It should be properly first defined. And when you think of introducing any APIs, you need to think in long term when you design them. And then make sure you document it well. You test it, make sure your API is secure, then deploy it. And monitor your API over time and see what you can do with it. For example, how do you think that YouTube gives you all the recommendations, right? So if they monitor it and they see how you are watching, what is your watch content, and then based on that, it gives you recommendations. You could do something like that with based using APIs. So, well, we have talked about a lot about APIs. What are the good, good features of any good API? Should have the following features. First off, it should know what its real user does, right? And how it can handle errors. It should be simple and it should be operational. It should also be predictable, right? If you're trying to create an account with gmail.com, right? You should know that it's going to create an account for you. It's predictable, right? And it is also very well documented. If you take a look at any API document, it thoroughly states, and we'll just go over one of the documents in a moment. And also, a good API should be secure and it should be scalable. For example, what I mean by scalable is you are creating an API, and for a payment or an e-commerce website, and during Thanksgiving sale, there's going to be a lot of traffic. You have to make sure that your APIs are available, and based on the traffic, your API should be scalable automatically. You can do that with using cloud services. However, there's an overlap between cloud services and your backend. So I'm not going to touch on that, but this is something that you should know that it should be scalable. So here is an example for an API. For example, if you go to medium.com and you're trying to log in, it gives you an option of, hey, you can log in with these things. Those are universal logins, could be one of the examples of API. And if you go to any e-commerce website and they say, hey, pay with PayPal functionality, right? So that is also there's an API involved in that. And if you go to kayak.com, it pulls out information from different travel websites like Orbitz, Expedia, etc., and it gives you a comparison. So those are the examples of APIs. So before we go to the next topic, I wanted to know if there are any questions so far, Alexander.
Yeah, I just checked the chat. It doesn't seem that we have any questions, but yeah, please feel free to submit them. Because so far, no questions.
Okay, I did mention them. There are two tools for API development that you can use. One is Swagger and Postman. It gives you beautiful documentation stuff, because writing these documentation can be very tedious. So they have a format for this as well.
Yeah, cool.
So moving on to REST. REST API, what is it? REST stands for Representational State Transfer. It is a software architectural style that relies on stateless communication protocol. What does it mean? I'm going to be talking about what is stateless in a moment. So what REST does, it structures the data in different formats like XML, YAML, or JSON. Mostly JSON is used widely. And who is the originator of this style is this guy, Roy Fielding. He is the originator he was writing his PhD dissertation, and then he submitted this as a dissertation topic. So that's how this whole thing became a popular one. REST does not have any standards to follow, like HTTP protocols, but then this is one of the ways that you could do this. So it's an architectural style, understand that. So some of the terms that you need to be aware of. So first one is client. It could be a person or a program that uses the API. And resource is any piece of information that an API can provide it to the front end. And server is, as you know, it gets the data requested from the client and then displays it and gives it back to the client with the information that you want. So the key word here is you need to understand what is a resource. So some people say that, hey, we have a RESTful API, right? What is it? What does that mean? Simply put, it's just that they have APIs that adheres to REST architecture. There are a set of constraints or principles. If you say that you have developed an API and it's RESTful, there are some constraints or principles that you need to follow to say that your API is a RESTful API. What are those? See, these are the constraints that you would have. First is the only information the client application should know is URI, which is Unified Resource Identifier of the requested resource, right? You try to log in and try to get some information. That has a specific identifier. And then the client and server should be isolated from one another, and you can develop them separately, right? And what is mean by stateless? Stateless is a RESTful web service should keep the client state. It should not keep any client state on the server. If I'm doing something on the front end, backend should not, or the server should not keep any of those states in there. So this particular restriction is called statelessness in REST API. And caching is one. For example, if you're trying to create an account create a Gmail account, right? So if you're trying to create one and if you're trying to submit the same information, it does not let you do that, right? Because it's already cached in the memory. So it'll say that it'll throw you an error. So caching is something that it helps consumers to avoid submitting the same requests twice. A layered system. This makes RESTful an scalable architecture because we decouple them from client and server. So, and it gets information based on different layers. It goes through and gets the response from different layers. So that's how, when you are trying to create a REST API, it should be a layered system. And finally, there's something called as code on demand. This is an optional constraint. This allows you to have a code snippet or an applet that would communicate with the application. For example, if you want to, if the client side wants to download a JavaScript or any other Java applet or something like that, in order to do that, it should encrypt so that the servers are not aware of what's happening, right? These are the constraints that you need to follow to say that your APIs are RESTful. So here's an overall architecture of REST. We were here, if you see that, you're using something here called as get, post, put, delete, and there are some HTTP request and response, which we're going to talk about in a moment. So HTTP methods. Like I said, HTTP is a set of protocols. It is a set of standards that is used for transferring information. REST basically uses it. It does not have any standards by its own. Do not confuse REST with HTTP. It uses it, but REST does not follow any specifications. So there are some HTTP methods that REST uses. Those are GET, which provides information about your API resource. Post is something that when you want to create a new resource, you would use post method. Put is something you update. For example, you update your credit card information. When your credit card information changes, right? The expiration date changes, you go ahead and change it on the on any shopping websites, then it becomes an update there. So then if you don't want any resource, if you want to delete it, you can use delete method as well. So,
Sorry. Yeah, sorry, Deepa. I will pause you for a second because we did receive a few questions,
okay,
and I just don't want them to come late.
sure.
So, one clarification question: you mentioned like all web services are API,
Mhm,
right?
mhm.
Okay. So the answer is yes. Then another question we had: um, where are APIs stored? I'm not entirely sure what you meant by that. Um,
It's just a protocol. It's just a communication channel, right? It does not store anything.
yeah.
That's why it's called as stateless in REST.
Yeah. So you store all of the data is still stored in databases, right?
Yes, it's
And
stored
then
in the
and then
server, but
you use APIs essentially to get this data from the database and put it somewhere where you want, either to the client or on your website or to another system or something like this.
mhm.
So then, um, okay, just um, how is Postman used to make an API?
Oh, okay. It's just used as a testing tool if you're designing, if you're developing your APIs, right? And if you want to test it out, you cannot do it on a real production environment, right? If you
Mhm,
want to use it for your, if you're trying to develop and if you want to test it out in a development environment, then you could use Postman to test it out.
mhm. Yeah. So to clarify, essentially, Postman, you don't not use Postman to create an API. You use Postman only for testing and
Testing,
documentation, if you want.
yeah,
So,
mainly for documentation and the testing.
mhm. How to make API scalable?
Like I said, it is an overlap of cloud services in here in this case. If you have an API and you're connected to a server, a service like AWS, right, or Google Cloud Platform, and your servers are set there, and your servers are set in a such a way that it's scalable automatically, right? You can do horizontal or vertical scaling, and based on the traffic of your application you can scale that. That's why I said that there's an overlap between scalability and cloud services in this case.
But
I
it's
hope.
mostly about architecture of the system, right?
Yes,
So it's you need to learn about that, and it's a little bit outside of the scope of this talk, right?
yeah, until as long as your application is like an enterprise application, or if you're having a blog, for example, or a newsletter stuff, and all of a sudden you have a user over 250,000 users all of a sudden, then you need to figure out a way to scale your application.
Mhm. Then another question. Yeah, there are a lot of them actually. So, okay, let's take two more and then we'll go and then take another set of questions. So, when you use REST API data, okay, when you use REST API, data will come in JSON format, right? Or do we give instruction for that to come in JSON format?
You can use any data formats. Like I said, you can use XML, YAML, or JSON, but the most widely used data format is JSON.
Mhm, mhm. Yeah, JSON is kind of a universal format
Yeah.
that's convenient. And
I'm going to show you an example in a moment, so
yeah,
bear with me.
yeah. Okay, maybe one last that I see. Do you want to take it, or we should go and
Oh,
then?
sure, go ahead. Let's
Okay.
let's let's get it.
So, um, does API only provide information to a user application, or can it be used to manipulate host of the API?
Mm,
I'm not entirely
I
sure
don't
what you mean.
understand this question. I'm
Yeah,
not. I'm so sorry, Saeed. If you can rephrase it for me, I can definitely answer that. If you're
yeah.
asking, it provides information to a user. It does, but then there is no the data exchanges, the server, whatever it passes on, the client does not know, but it just displays.
Yeah, if you could rephrase the second part to clarify it a little bit, so that would be appreciated. Cool. So, okay, I think that's all for now. So, to the audience, feel free to submit any other questions, and yeah, we'll continue. Thank you, Deepa, for
No worries.
yeah.
So there is a people say that, hey, I use CRUD operations on my API. What does that mean? Basically, they are using they are using REST API along with these HTTP methods. And CRUD is easy way to remember for your post, get, put, and delete method. Basically, you create a resource, you read or get the information. That's one thing. And then when you update your resource, it's and delete a resource. So remember, you don't have to, if you don't remember all these method names, which might be confusing, and note that there are a lot more methods too. There is patch, there is options, there are different ones, but these are the common ones that are used. And remember them as CRUD operations if you have to. Okay. So what is an anatomy of REST API, right? Because there are 4 things that you need to know. For example, no, these are the things. Endpoint is nothing but your URL, right? The main domain. And then there are methods that pass in, which we talked about: get, put, post, and delete. And there's something called as header, which would contain request and response. And the body usually contains metadata. So here's an example. If I go to api.github.com, and I'm trying to get one of the users here, Shan Prasad. So here is this information. If you go and see in this, if you see, it gives you clearly that this is a get method, and there's something called a status code, which we'll talk about in the next slide. And it sends you response header only, right? If I go ahead and check for the received, one of the things that he has subscribed for. If I go and look into this endpoint, if you go here, it says response header and request header. So this is what an API would have. And note that these are all in JSON format. And if you see, if I have to fetch Shan Prasad's subscriptions, the entire data comes in here. And if I have to look in for a specific one, like with the ID one, I could do it, but then it gets complicated with REST. So this is what I wanted to show. And there's also something with, so we talked about the status code, right? We saw something called this here. It said status code 200, which means everything is okay. And remember, it's between 2 software applications that talks to each other. On the right, there's a bunch of error codes. This is one of the error codes. These are the error codes defined by Stripe API, which is a payment application. And if you want to have Stripe APIs to be used in your website, you would integrate it with them using an API key. And when you integrate, or when you use, when you're trying to connect both of your application and along with Stripe, if something goes wrong, if you have a website where the user has to sign in, log in, and then they try to log in with an invalid password, there's some kind of an error thrown. So those errors are usually, you would define it, which starts as 400 errors. And then the 500 errors are ones that would come if you're trying to do a checkout from Stripe's. The moment you press checkout or pay, and then it goes to the Stripe API. And if there is any issues, it'll throw some error, which would be in 500s. Always remember, 200 is we are good to go. 400 is you made something, it's your mistake. 500 is, oh, I did something, my my system is, there's some kind of a problem within my system. So remember these error codes. You don't have to remember everything, but they usually ask for what is 401, what is 404, what is 400. You need to know some of them, but not a lot of them. Understand that there's something with the user did. Those are all 400 errors. So this is the Stripe API. I picked this up and they follow REST. And this is
Sorry,
where
could you zoom in a little bit? I just saw a couple of requests. People just say it's the font is very small, so
oh,
yeah.
yeah, this one.
Not on this, not on the presentation, but like when you do a
Oh,
demo, yeah, the code,
this one.
the
Oh,
text
okay,
is
okay.
very small. Yeah.
Yeah, you can go try to get, you can, if you have what do you say? I can post this. You, if you have a GitHub account, just go ahead and see. But GitHub allows only 40 to 60 calls to be made. There are some restrictions when you use GitHub API. Only a certain amount of can be used for fetching the data. But here, if you can go ahead and try to see, and make sure you open the uh, developer tools in Chrome, which is function 12, I think F12. If you press that and go to network tab here, and then once you go there, you can see this data.
Mm-hmm.
Does it make sense? I could go a little slower too.
Yeah, yeah. This is better. Yeah, and can you do the same thing with the data on the left side?
This one?
Yeah.
Actually,
Where
I
the
can't
data
do
is
it.
in Word.
If I do that, my slides are going to be.
Uh,
Okay, here you go. Okay, so
yeah,
I'm
but
trying to get,
yeah, but as Deepa said, essentially, I pasted all of the links in the chat as
yeah.
well. So all the playgrounds and everything that Deepa shows you, I posted the links in the chat as well. So you can go there and just feel free to play around with it. Yeah, but
And
essentially, sorry, you can, as Deepa said, you can just open these Google Developer Tools. So either F12, function F12, right? Or right click, and then you can inspect
yeah,
as
and
well.
then you can inspect and then go to what is this thing? Network.
Cool.
And then you need to click on the endpoint, that the one that you're trying to see. Here I'm using this user, and then the endpoint I'm using it as, subscription here. So if you go
Mhm.
here and then see it, there's a bunch of, you have the request and the response here. And if you look into it, you would, and you can also go into the response one here, which displays the same thing on the left. And you can see preview. There are only 4 records here, but then if you see, it's all in JSON format. There's a lot of information here, even though there's only 3 records here, right? So if
Yep.
you, one of the disadvantages we'll be talking about is REST fetches everything. So basically it overfetches everything. And it's if you want to get only a specific detail, for example, I want to just get what is the name of this event or subscription, whatever the thing is. If I want to get something from this and I want only specific detail, okay, I want to get the branches for this URL for this particular ID. I cannot do that. You could do that, but it's you need to know how to do this. So basically, when you query them, it comes out everything in REST. We'll be talking about the one of this is one of the drawbacks of REST as well.
Yep. I think everything's good right now.
And you can also there are a lot of websites which has not only Stripe. You can look into um, every API. For example, any payment, even Apple Pay has it. Google Pay, if you want to go and look into it. Google Maps especially has a specific API documentation that you could use as well. So shall I continue, Alexander?
Yeah, I think we can. I actually, there is one question. So yeah, the person has clarified. So they essentially said, sorry, my question is a bit confusing. So what they meant is API read only, or can the user modify any of the data in the database via the API?
That's why you use those methods, right?
Mhm. So essentially, yeah, to answer
You
your question, essentially you can modify data
Mhm.
with an API, and as Deepa said, there are like different methods, right? So if you use get, it means you will get just read only, right? But then if you have post, if you use post method, then you can put in your record in the database via an API, as you said, right? Or again, patch, put, delete, yeah, a lot of other methods. So it's not read only. You can also manipulate the data in the database with the help of an API. Yeah,
Mhm.
cool. So,
Thank you so much. So let's move on. So one of the things that REST, these are the main benefits. It's it's very lightweight. It doesn't have any high learning curve in with when it comes to REST API. It's scalable, and then it's also flexible. We say it's flexible, but there are also there are disadvantages to REST, which we will be talking about. So the endpoint consistency, like I said, it fetches a lot of data, and sometimes what happens is if you it fetches and you cannot, there could be some security issues too if you do not encrypt your data properly, right? It all depends on how you first design your API and how you're going to what kind of or methods that you're going to use, and how secure can you. It's about how you are going to architecture your whole API. That's the whole crux of it. And then API testing can become a little bit tricky. You need to connect it to Postman or something similar, and then you should make sure that there's a setup involved around that. And when I say um, um, there is also, you need to define all these error messages. So you have to define your code and then make sure there are error handling messages too for each of them that you want to do architecture your API for. So you guys can go here. This is a free website, but you have to sign in, where you can play around and see how you can create a get request, create a post request, create any methods that you want here. There's an option. I have them already created. For the sake of this demo, I went ahead and created. But if you go to workflows, it gives you beautiful, when you try to sign in, it gives you how um, there is a tutorial as how you can create these things. You can follow along, and using workflows, if you go to workflows, you can create all these things. I created some of them ahead of time. So I have a get a request, post request, and delete request here. And one of the things that I wanted to show was, um, so one of the things that I wanted to show was, okay, yeah. Here is the code for what is a body return, what is a header, and here also it shows you. And there is also, if you look into the code, it gives you a snippet as how you have to define it. For example, we are using get call, but then how do you want to define it? What are the things that you wanted this particular get call have to do? So there are some code snippets. Go ahead and play around with it so that you get, it's very similar in real world as how you would use this. And
yeah, I put the link in the chat,
yeah,
so feel free to go there.
and also see, like I said, there's a get one, and I think I messed up with this. Okay, it has a response, body, and you have header with a status too, right? Very similar to what we saw in the Git API, GitHub API. So who uses REST API? Many companies use. Salesforce was the first company to implement REST API. This guy wrote the dissertation, and then somebody took this and then implemented for their business use. So these are the companies that uses it, but Salesforce started it first. And any questions?
Okay, let me take a look. Yeah, just for some reason it doesn't. I see the questions from YouTube, but I don't see questions from LinkedIn, so I need to go to the LinkedIn page and then scroll. So just a second.
Okay.
Um, uh, so the backend check. Okay. What's the funniest thing about REST APIs, you know? uh, um, yeah, there was one question about caching,
Mm-hmm.
but I'm not entirely sure what they meant. So, yeah, Roland, if you could.
Um, Sure, I'm trying to recollect from my thoughts. So caching is when in if you want to like I said, I gave you an example, right? You're trying to create a Gmail account, and you already plugged in all the data, all the information, and you say create account, right? And you're trying to submit the same information again. It's already cached in your browser, right? And then when you're trying to do it, it's just it throws an error again. It's cached at the it's cached in your API. But when it and the business logic that I showed at the beginning of API diagram, if you vaguely remember, so the logic is stored there, and then it gets cached there, and then when you try to do the same thing again, it's going to throw an error for you. So there are times that, for example, if you how do I put it, like some are even this GitHub this thing, right? I have cached this. I've been using this API for past 3 days to figure it out. But if you try to keep the if I go ahead and try to fetch somebody else's, let's do Alexander. Do you have a GitHub one? I have mine, but then if I try to use somebody else's, give me a name. If you try to use it, it's not because GitHub allows only 40 API calls per hour or something like that. But if you exceed that, it's going to show you an error. But I'm able to do this because it's got cached in from my end. Does it make sense?
uh, yeah, I think it should be clear. Yeah, just maybe to also conclude it. Essentially, yeah, cache is something that like when you make the same request, instead of doing the same logic, it just gives you the process data, right? So it kind of saves some resources in this way. So you don't do the same calculations over and over again when you request the data from a specific endpoint. You just, yeah, again, if it gets cached, then it just gets stored somewhere, and then you receive
Mhm.
it back without any calculation.
But
So,
note that if I try to use more than 40 times, because GitHub has a count, they have a limitation as how many people can, because if I just try get api.github.com/users only, it's going to fetch a whole lot of stuff in there because there are so many users. So it's
yeah.
going to take some time, but that would not allow you. Hopefully, they don't allow you to do that, but there are some limitations. That also depends on how you architecture your application,
Mhm.
your APIs.
Cool. Yeah, I don't see. Yeah, I don't see any other questions, so we can just move on. I think so.
Okay, let's
Cool.
go to this guy
So the
here.
most exciting part now, GraphQL.
Yeah,
Yeah.
so GraphQL, right? Oh, everything came up. So it was introduced by Facebook or Meta in 2012 as an internal tool, but internal user, and then they open sourced it in 2015. So when I say GraphQL, it does not mean that it only uses graph database. It can also use document-based database such as MongoDB or Postgres too, right? And REST, as you saw, it has to be structured very well. And whenever the data get more complex in REST, it had the possible there's no possibility of fetching a single request from REST. So this is where GraphQL comes handy. It structures the data with a powerful syntax, powerful query syntax, and it is used for traversing, retrieving, and modifying your data. So each and in each of these architecture solves a different problem. So when I say that GraphQL has got many uses, but then we'll talk about the comparison later. But understand that it's quick, it's fast, and whatever you want of it, what you ask for, you get from GraphQL. So here the architecture is, for example, you have multiple applications like multiple platforms, web, mobile, IoT, any kind of applications you have, right? And then you have clients there. Here's an example where the client, you have a page for product, payment, user, inventory, etc. Here, GraphQL uses only post method. It does not use any other methods that we discussed in REST. That's one of the things that you need to know. So it's a bit of confusing with the query language part. Understand that the query language for GraphQL is for data APIs, which comes from the front-end perspective. There are two parts to it, right? There is a GraphQL, which is a browser-based interface for editing and testing your GraphQL queries. And there's another one, which is called Apollo Client. It is used to build the client applications. It integrates very well with JavaScript front-end frameworks such as React, Angular, etc. So on the server side, it is a runtime layer, and you need to implement how your backend has to be. So there are three parts to it. We'll see the demo in a moment, but understand there are three parts to it. The center of GraphQL server implementation is your schema, which describes the functionality available to the client, which is connected to it. So this is a main piece of GraphQL on the server side. And next you have query. It basically gets the query from the front end and retrieves the data. Either it could retrieve it from a database or a legacy API too. And there's something called as resolver. Resolver, basically what does it do is, once you validate, the schema gets validated, and if it's valid, resolver would go get the information and then give it back to your query so that the data can be displayed on the front end. So I hope this here's an example where a web server is built on Node.js and Express framework. And a request is made either from this React application, which has either a Apollo client or GraphQL. And then there is a query which is passed by the query parser, right? And it is passed against the schema. It goes to a schema, and the schema gets it gets passed, and then it gets validated. Once it gets validated, the resolver function takes up, oh yeah, it's validated. So let me get the data either from a database or from, like I said, an API, right? And this API could be REST API. And just to mention it here, both GraphQL and REST API can coexist, right? You could have your front end with the GraphQL and all your backend with REST API as well. It's how you architecture. But again, understand that it can coexist together as well. So here are some of the benefits of GraphQL. It is if you are creating an application for different platforms, mobile, web, or a IoT device, stuff like that, so you can use GraphQL. And there's no overfetching or underfetching in GraphQL. It's very strongly typed. We'll see the code snippet in a moment, and understand that it's designed to be declarative, flexible, and efficient for data fetching. So what are some of the challenges, right? The first one is queries in GraphQL are in indefinite depth. So because of that, there are some performance issues. So regarding complexity, if you're trying to deal with an API where the data is relatively consistent over time, you can stick on to REST. But if you have an API that kind of keeps changing, which are very dynamic, and if you have like I said, different platforms too, which keeps rapidly changing when your data is rapidly changing, and you need to keep re-architecturing your API platforms, right? So in that case, it becomes more complex. Another thing is web caching is not allowed, or it could be a challenge in GraphQL. It does not have an inbuilt thing. You have to rely on another um, library so that you can have built-in caching support. Also, their error handling is one of the things that a GraphQL has. Like if you're trying to query something, and sometimes you get only, your status code would be 200. However, the query would not be successful at all. So in that case, error handling, again, could be a challenge with GraphQL. It does not support very well with error handling. Again, you need to use something else to make it work. So these are the companies that uses GraphQL. You can go to this graphql.org/users. You would find a lot more. And some of them, like I said, coexist. GitHub has, Twitter has both GraphQL and REST. So you can look into their documentation to see how they have defined it. So these are the applications. So here's a demo for GraphQL. So this one, you can post the code sandbox link, Alexander.
Yeah, I will do that in a second.
So here, if you see, we are creating this is a server-side implementation, very small implementation, where we are defined the type. This is your schema. And we have a type definition for book. And then here we are creating a query type. And inside that, we are creating records. Here's a resolver, which gets the query. And if you guys can you see it, or should I make it a little bigger?
Yeah, maybe zoom in a little bit. That'd be helpful, I think.
Yeah, okay. Let me try to do that. So here's a schema that we have defined. I'm trying to, okay, let's see. So I think if they have the link, they can also look at it. So this is where you have defined a schema, and this is a type. Understand that there are different, because it's strongly typed. You have to mention everywhere. So you have to say what is this? What is if you're trying to have a record, you need to make sure that you define the type as well. And here we are creating a type query of books, and then within that you have data here. And then what does it do? The resolver basically gets a query and then gets. Here's the example for that. If you go and click on the right hand side, if you go and if I try to, you can go click on the right hand side. If I go ahead and refresh this, and it says query or server on the right. If you click on this, you would be taken to a sandbox like this. So you need to be signed in with your, this is also a free tool, but then you need to sign in if you have to run these queries. So here is an example as how do you query for this get books information. So if once I query this, this is the information that I get. And note that I could change it by author, I could change it by title. If I have to be very specific, I could do that too. Okay. Now, let's do a quick comparison, right?
Maybe just before we do that, let's maybe cover a few questions about GraphQL. Okay, some people that mentioned like authentication, and they said that we missed that. Yeah, we essentially, yeah, we didn't mention like authentication part, but you can add authentication and authorization right to your API, so you can
Mhm.
protect your routes. So
Mhm.
only like, for instance, employees of an organization can access like certain data. This is also possible to do.
Mhm.
Then one question: where to find free APIs?
Oh,
So
I think the pipe dream thing that mentioned, this guy, you can just play around with this.
yeah, so this is a good example. Yeah, generally, like I think even if you Google like free API, you will get a lot of results in the Google search. So yeah, obviously, like I'm pretty sure that the majority of APIs are, or no, some APIs are definitely like not accessible to public for obvious reasons, right? Because
Mhm.
um, so then
This is the one which was free. Actually, I was trying to figure out for this particular demo. And then if you want to, like I said, go ahead and play with it and see how this works for you. But then there are a lot more things that you can test. There are a lot of free resources. If you check for, particularly if you are searching for API testing, then you might find something.
mhm. So another one, I yeah, if you go back to this demo code for GraphQL
Hmm.
for a second.
Oh yeah.
So Shan asked, can we create GraphQL using JavaScript? So essentially, like, is that I saw it's also like in a JavaScript file, right? So it's index.js. So it's essentially it's a
Yeah.
plain JavaScript, or no?
Uh, it is because we are doing it on the server side. We are not doing anything with the front end side, but you can do it with Apollo server. You could.
I see, I see. Okay.
GraphQL.
So then, so the answer is yes. And then is GraphQL similar to Microsoft Access?
I have not used Microsoft Access. I have used GraphQL and REST for sure, but this is something I don't have an information for you.
Mhm. Also, there is another one. Can I block the data? Yeah, again, a little bit confusing question.
Maybe
Um,
encrypt your data.
um, so, can I block the data sent by hitting API endpoints via Postman?
I don't understand. But then why would you want to hide if you're just testing? Why would you want to hide it? Because you want to test your APIs, right? I'm assuming that if you're trying to test it, as I'm
Mhm.
not so sure what you're
Yeah,
asking, but then
yeah,
yeah.
sorry. Yeah, could you elaborate your question on that question a little bit? Yeah, thank you. So then another one was a bit confused about GraphQL architecture. Can you go back to that slide where you had
Sure, sure.
like front end and back end?
Uh-huh, uh-huh.
Oh, sorry, like client side and server side.
Yeah.
Yeah.
Basically, I was trying to say is you can use it for client side and you can also use it for the server side. But how you can have the same query parser here and have a totally different server side as well. You can have REST API for that.
Yeah, yeah. So essentially,
So
Uh, yeah, maybe to reiterate over this diagram, you have the client side, right? So as Deepa said, GraphQL is just like a playground for you to play, and then Apollo is something that you would use like in a React app, for instance, right? Uh,
yeah, this is a client side one, but you could also use it for here. If I say there's an Apollo server one too. So that's why there's an Apollo server, there's an Apollo client in here. So it depends on how you're going to architecture, whether you want it for front end only, or you want it to also have it with your server side as well.
And then, yeah, regarding the server side, you have like those three necessary elements, right? Query.
Actually,
Parser,
the
result.
query parser is something that it's in between, because you request something, right, from the client side. The query parser would take that request and then it passes it on to schema. And schema basically validates your request and sees, hey, if it's valid, then it'll move on to a resolver, and resolver will go fetch it from your from the database.
Yep. Cool. And then, yeah, you have the database connected, obviously, right? And then, as Deepa said, you can also use REST API with GraphQL, right? So you can combine like different elements of it.
And this is just an example for, you could have multiple APIs too, right? This is just a basic one. You can have multiple client-side GraphQL, which is talking to different, backend like REST APIs too. So this example, I gave it here as if you have a server side from GraphQL, but you are trying to fetch something from outside. Say, for example, you are trying to fetch something from Stripe or Spotify, something like that. So you could do that too.
Yeah. Cool. I think that's all for now. Let's probably move on. Yeah.
I'm not sure where I was.
You stopped where you wanted to compare REST.
Oh, the quick comparison. Yeah.
This one.
So okay. So what just to have a quick comparison, I showed you that in REST API you can use multiple endpoints. We saw all the methods, but in GraphQL you're going to use only post, right? The rest of the things are the same. The data exchange is the same. It is, both of them are stateless, meaning that the client information is not stored in the server, and then the server stuff is not shown to the client as well. So that's something that you need to know. And it supports both front end and back end too. And so another part is your URL, right? Here I have for REST API, I'm using an endpoint with user, and then after that the body follows. You're using query parameters here, where a path parameter here. Sorry about that. In GraphQL, you use only post.graphql. This is a fixed one, and you are querying based on that. Here, anything could change. It could be a post method, get method, or a delete one. And whereas here, it could be only post/GraphQL. Whatever you want to do with it, you do with it inside the query. So here's an example. I just want to point out that this is a get method. There's an endpoint that we are trying to get the person one, who's John. We get all the details here. If we want to get only the first name and the last name, this is GraphQL is pretty easy. You just have to give, hey, I need only the person's first name and last name. It gives you the data as you fetch what you need. Whereas in REST API, you fetch everything.
And sorry, just can you go back to, and like you see in the REST API, you have like get endpoint, so sample person /1, so it knows the ID of the person, right? You want to get, but how does GraphQL know what ID you want?
You could query based on that. This is just a dumb example, so you could do that too. I'm just trying to say that if you have a nested data, you could get it based on. I could say that probably the query would have been ID equals 1, and then with what person, first name, last name, right? It depends on how you write your queries too. So, but it gets the information, just the information that you need. Here, everything shows up in REST. That's one of the main drawbacks in certain cases, but some cases you need everything too.
Yeah, makes sense. Cool.
So this is something that I pulled out from 2021 State of API report. And this is based on most popular API architectural style. And till date, like as of 2021, REST API, about 50% of the people use it and they say they love it. But whereas GraphQL is catching up, there is a lot of support for both the groups, both the REST as well as GraphQL. But everything serves for specific purpose. And the key takeaway from here is when you are looking for, when you're trying to architecture your application, and if there is a need for cache, then caching, and there is a limitation on your bandwidth and resources, then you would use REST API. Whereas GraphQL, if you have an application for different devices. For example, it could be mobile, smartwatches, IoT, where the bandwidth matters, you would use GraphQL. And where application needs nested data, you have a lot of nested data and you want to fetch only specific data in a single call, then you would use GraphQL as well. So to summarize, in simple terms, we saw what is an API. It's a communication exchange between two software systems. And then also remember, all web services are APIs, but not all APIs are web services. Web services require network, and REST and GraphQL are approaches to API architecture. And there are a lot of factors to consider before, with your project size, before going and saying that, yeah, I would use REST or I would use GraphQL. It depends on what is your project all about. So with that said, my name is Deepa. You can connect with me in LinkedIn. And I'm also an organizer for GDG. Please join GDG San Jose. I do events quite often, but then it's going to be in person going forward. We are trying to do a lot of in person. If you're interested, if you're around the Bay Area, please let me know. And these are my references. Any questions?